Hey, welcome to Chapter 7. Congratulations on getting Chapter 6 done. This chapter is about using patterns to describe change. The first lesson is going to be on interest, then we're going to get into exponential growth and decay. We're going to look at modeling it. Much as we did for a linear regression, we'll be doing a exponential regression. We'll then be talking about what is a function and what's function notation. I think you've heard it spoken about a little bit. And we're going to compare the linear increase and exponential growth. I do want to take a look at this opening section on the graph on page 397. That graph has three graphs on it. One is a constant situation where there is no change. The second one is a constant change situation where you have an initial amount and every year it changes by a fixed amount. And then the last one is a percentage change type of a situation, which becomes an exponential growth. The difference between them, in the constant one, there's no x. X is constant. X just, everything stays the same regardless of x. The next one is x is being multiplied by a coefficient. That's the constant change. And then the exponential change is x is the exponent of a base, and so it's being raised to a power. Let's take a look at 7-1. 7-1 is about compound interest. You've got some things you need to know about. I'll come back to this power, nth, base, exponent, and we'll talk about principal interest, annual yield, and compound interest. Those are in the text. You want to read through that, make sure you understand which one is which, because those will fit into an equation that we'll be solving. Let's take a look at power. Powers and repeated multiplication. Raising a number to a power is a repeated multiplication. In the example here, we have 10 raised to the third power, or 10 to the third, and that is equal to 10 times 10 times 10, or 1,000. We have 3 to the fifth power. That's 3 multiplied times itself, and there's 5 of them. 1, 2, 3, 4, 5. So powers is a repeated multiplication. Something raised to a power is that base, 10 to the third power, 3 to the fifth power. What else do we have? Okay. X to the nth power, or x to the n. We could read this a lot of different ways. The number, in this case 10 or 3, this is the base for the exponent. Is the base of the power. The exponent is the 3 and 10 to the third, or the 5 and 3 to the fifth, is the exponent, or the power that it's being raised to. So that's our exponents and power. Let's take a look now at some compound interest problems and see what we can do with those. You have some examples in the book. You certainly should read through it. You absolutely should read through and know what the terms are, so you know what they are when you're reading it here in the problem. The example 1, suppose you deposit P dollars in a savings account upon which the bank pays an annual yield of 3.5%. If the account is left alone, how much money will be in it at the end of the year? Well, let's take a look at this real quick. You put in P dollars, that's the amount you put in to begin with, and an annual yield means it's the amount that's in there times 3.5% will be added into it. So you have your principal, you're going to add to that the 3.5%. Now remember, 3.5% is not a useful algebraic term. We have to convert that to a decimal form, and that's 3.5 or per 100. So that would be 0.035. So that's tenths. It's 3.5 hundredths, or 35 thousandths, if we want to go that far. So it's 0.035, 0.035, and that percentage is being applied to the amount, the principal. The amount was there. That was P. And so this becomes, this equals the total amount at the end of 1 year. Now we can simplify this because P is a factor of both terms, and this is just 1 times P. We can change this to P times 1 plus 0.035. And then this can be combined, so 0.035 plus 1 is 1.035. And we generally put the numbers in front of our variable, so 1.035 P is the total amount in 1 year. So here we've got a basic idea of compounding interest. The interval is 1 year. This happens 1 time. And we can begin to build on it from there, and we can simplify it to 1.035. Now our next problem, example 2. Suppose you deposit $200 in a savings account, upon which the bank pays an annual yield of 3.5%. So this is kind of like what we did when we had P. So it's 200 plus 200 times 0.035, or that becomes 200 times 1.035, and that equals $207 at the end of 1 year. Well, in year 2, so this is year 1, year 2 we have $207 plus 207 times 0.035, and that again is 207 times 1.035, and that equals $214.25. Now this is an approximate because I had it was 0.245. And then year 3, I'm going to shortcut this a little bit. This is just going to be $214.245 times 1.035. And that looks like it's approximately $221.74. Yeah. Yeah. Okay, and we were at 221.74. So that's how much we got after 3 years. Now, if we take a look at this, we might be able to see a different way to be able to do this. We might be able to perhaps shorten this up, because if you'll see what happened here is we had this 1.035 multiplied every time in this problem. So we want to remember that. We're going to be coming back to this idea and see if there's a way we can speed this up a little bit. Alright, this is kind of a long way to go to get to this. So I need you to make a record of this should you need it. I'm going to erase this, and we're going to start this over again and do the calculations a little bit differently. And we'll just leave our very first year calculation in there and get rid of the rest here. Okay, and back to our pen. So at the end of the first year we had 207. but that's represented by 200 times 1.035. In year 2, we had 207 times 1.035, and I can rewrite that as 200 times 1.035. This equals $207. And I multiplied that result, the 207, times 1.035. That's year 2. And then when I took the year 2 result, in year 2, that result, I multiplied that one times 1.035. So in year 3, I had 200 times 1.035, the first year's interest, times 1.035, the second year's interest, times 1.035, the third year's interest. What I can see that I've got here is repeated multiplication. And repeated multiplication is a case of a power. So how many times did I repeat it? 3 times. The base is 1.035. So to get a more direct result for my 3-year problem, rather than doing it serially as we did before, I have 200 times 1.035 raised to the 3 years, raised to the third power. And if I run that calculation, I then have the result that I would have gotten, I should have expected, which was 221.74. I can see then that this compounding of interest occurs, and as it occurs, it creates a power problem for me if I have the same interest being applied every year. Well, how much interest did I earn? Well, that's pretty easy. I started with 200, I ended up at 221.74. So for my how much interest did I earn question, I earned $21.74. What's kind of cool about that earning is you didn't have to work for it. You just had to not spend your money, and you ended up earning some interest, which I think is kind of cool. Let's take a look at another example here. And this is when the twins were born. Their parents put $3,000 into an account for college. What will be the total amount of money in the account after 19 years at an annual yield of 5.9%? Well, we started with $3,000. We got $3,000. Our percentage is 5.9%, so that's times 1.059. The 5.9% is 59 thousandths, or 5.9 100ths. Excuse me, 59 hundredths. The 1 is the initial amount, and I have an annual yield for 19 years. Now, I don't want to have to do this addition 19 times, especially now that I know I can do the shortcut of raising it to the power of the number of times I'm going to apply the interest. So here I've got my equation set up. I have a chance to take a look at it and see what kind of improvement will I get on my finances for letting it sit for 19 years. So we've got 3,000 times, and then I'm going to put a parentheses on this, 1.059, parentheses raised to the 19th power, and that gives me that as a result of hanging on to this money, I have $8,915 and I'd say 48 cents. It's a 0.47521. So this is our dollar amount at the end of our 19 years, which is not too bad to have to apply to your college education. The interest that you get on this type of thing. It's sort of, why do you get it? And what you're getting paid for in interest is the bank's right to use your money. They loan the money out at a higher interest rate than they pay you. So they have money that they loan to other people, your money. While that's working, they're paying you for the right to use it, and you get your improvement on that, if you will, this bump in the amount. So that's it for 7-1. Best of luck with it. Good luck on the mastery quiz. Remember, bring your questions in to class. Love to talk to you about it. See what you have to say. Good luck on the mastery quiz.